Welcome to this explainer. I want to kick things off today by validating a struggle that I know so many of you, whether you're technical leaders, architects, or on an engineering team, face literally every single day. You're constantly being asked to ship brand new digital experiences, and let's be real, you're expected to do it almost instantly. But at the exact same time, you have these massive compliance, security, and reliability standards breathing down your neck. You absolutely cannot compromise on those, but you also can't afford to move slowly. It's a huge challenge to balance those demands in a modern enterprise environment.
And honestly, that brings us right to the core of the enterprise web dilemma. So many modern web stacks force engineering teams into this deeply frustrating false choice. On one hand, you can choose to basically strap a rocket to your back, moving incredibly fast by stitching together ad hoc components and lightweight libraries. You get the product out the door, sure, but you inevitably pay a massive tax later in technical debt. On the other hand, you can choose to build this rigorous fortress-like foundation from scratch, but then you have to accept a turtle's pace delivery timeline, which heavily frustrates the product teams. It often feels like you have to pick your poison. But there is a framework that directly challenges this false choice.
Enter Django, and it's really famous in citing paradigm shift. Batteries included. Now, I want to be clear here. This speed advantage, it isn't magic. What batteries included actually means is the total elimination of repetitive decision-making. Instead of spending our first 3 sprints debating which routing library to use, which ORM to implement, or figuring out how to patch together a completely fragmented authentication system, Django just packages the capabilities that enterprise applications repeatedly need into one cohesive framework. It is all about giving you back the time to focus purely on business logic and user value.
Okay, let's dive into this. Here's our exact roadmap for evaluating how Django solves the enterprise dilemma. Number 1, speed through built-in tools. 2, security by default. 3, scaling for enterprise growth. 4, enterprise architecture. And 5, practical enterprise use cases.
All right, let's kick things off with Section 1, speed through built-in tools.
To get that massive development speed, you really have to start with a unified system. When we say built-in tools, we are talking about a truly cohesive end-to-end toolkit. Out of the box, Django ships with an object relational mapper or ORM, routing, templating, forms, database migrations, authentication, and a really smart structure for reusable apps. Because all these components are designed from day one to just work together, you get rapid CRUD capabilities, create, read, update, delete, and seamless domain modeling right away. Plus, the streamlined migrations provide a highly reliable baseline. In enterprise environments where your requirements are constantly evolving and database schema changes are super frequent, having a controlled, auditable migration system built right into the toolkit is an absolute game changer for team collaboration.
But, perhaps the most famous built-in tool of them all is the Django Admin Interface. I literally cannot overstate how important this is. It is a true force multiplier for operational workflows. Just think about how many times your customer support or ops teams need to manage reference data, moderate content, or adjust user settings. Normally, engineers draw the short straw and have to spend weeks building these bespoke, boring back-office UIs. With Django, the admin interface acts as a lightweight internal product immediately out of the box, complete with permissions, filters, and custom actions. It saves teams endless hours of building basic tooling.
Moving right along to Section 2, security by default.
So, the obvious question you might be asking is, how do we ensure we aren't introducing massive vulnerabilities across a huge code base while moving this incredibly fast? Well, the answer is that enterprises don't just need secure code. We need secure defaults. Notice how Django basically acts as a vault against common attacks. It includes robust defenses for cross-site request forgery, clickjacking, and cross-site scripting by default, just by following standard patterns. It also offers secure session management and really robust password hashing. And crucially, by using Django's ORM and parameterized queries, it creates heavy resistance to SQL injection attacks. Django dramatically reduces the footgun factor, right? It makes secure behavior the path of least resistance for large, distributed engineering teams.
And this brilliantly illustrates how Django acts as an automated gatekeeper for authorization. Beyond just basic defenses, it offers standardized systems supporting user groups, fine-grained permissions, pluggable authentication backends, and seamless SSO integration. What's so incredibly powerful here is that Django pushes these security concerns into well-known configuration and middleware layers. Things like HTTPS enforcement, secure cookies, and trusted origins are all codified in standard settings. This makes organization-wide audits incredibly straightforward, simply because security reviewers know exactly where to look.
Okay, jumping into Section 3, scaling for enterprise growth.
Now, we have to be realistic here for a second. Django doesn't promise infinite scale on day one.
Nothing really does. But what it does provide is a highly extensible foundation. Let's walk through the mechanical evolution of scaling a Django app as your traffic, your data volume, and organizational complexity naturally grow over time. Step 1 is horizontal scaling. Django apps are designed to be deployed as stateless servers behind a load balancer, making scaling out highly predictable. Step 2 is caching. Django actually treats caching as a first-class capability, supporting per-view, template fragment, and low-level caching to rapidly reduce database load. Step 3 involves asynchronous background workloads. Django integrates beautifully with background job systems for tasks like report generation or sending emails, which keeps your user-facing interactions feeling snappy. And Step 4 brings us to advanced database scaling patterns, supporting things like read-write splitting and connection pooling. Because as you scale, the crucial rule of thumb to remember is this: the real bottleneck, the actual funnel restricting your application, is rarely the web framework itself. It is almost always your data access patterns. And this is exactly where Django shines. It gives engineers the exact tools needed, like clear query visibility, indexing controls, and prefetch techniques to let you optimize database queries early on and then evolve your database topologies only when it becomes absolutely necessary.
Which brings us to Section 4, Enterprise Architecture.
You see, true enterprise readiness is all about building software that survives multiple product life cycles, and Django's maturity is incredibly evident right here. First, it enforces a clear separation of concerns. The framework's modular ab structure helps isolate specific domains like billing or identity, which drastically reduces accidental coupling. Second, it has a wonderfully strong testing story. It provides out-of-the-box utilities for unit, integration, and functional testing, which is absolutely vital for traceability in regulated environments. And third, it allows for extensibility without fragmentation. With stable extension points like middleware and signals, teams can tailor the behavior of the application without having to fork or rewrite the core components. This standardizes how teams structure features, making large-scale handoffs between different engineering squads highly predictable.
Finally, let's wrap up with Section 5, Practical Enterprise Use Cases.
It is time to transition from theory into practical, real-world applications. When we map Django's capabilities directly to enterprise architectures, you can see it perfectly fits internal admin portals because of that fast CRUD and workflow tooling we talked about. It's totally ideal for B2B SaaS dashboards thanks to its strong data modeling. Compliance-driven apps in finance or healthcare benefit massively from its secure defaults and testing support. And content-heavy platforms just thrive on its flexible models. Now, what's really interesting about this slide is how modern enterprises actually implement these. Very often they adopt a hybrid model. They'll use Django for the robust core application layer, keeping the server-rendered pages for those vital internal admin tools. But then they expose functionality through APIs to mobile or dedicated front-end teams. It literally gives you the best of both worlds.
Which brings us to our final takeaway. Django accelerates web development by beautifully combining speed with built-in safeguards. It reduces the time your team spend endlessly reinventing the foundational layers of your software. So the question I want to leave you with today is this: are you ready to stop reinventing the foundation? If you want to stop turning every single project into a bespoke architecture exercise, it might just be time to choose a proven, opinionated base. Standardize your patterns, protect your data by default, and give your engineers a platform they can extend confidently as your organization grows. Thank you so much for joining me for this explainer, and I will catch you next time.